So the only thing we haven't done really, well, we kind of have, is word problems. You may have needed to write the picture given a couple of symbols, but now we got some words, right? Otherwise, nothing really too new. Maybe a little something extra on the problem, but it's sine law. It's got to be a triangle. There's only 6 pieces on this triangle. Got to know a few of them. So we have a roof. You guys know what a roof looks like? Well, there's flat roofs and there's roofs that make like A shapes, like A-frame houses. Obviously, we need this one to be like an A-frame one, not a flat one. So, a roof. Picture it in your mind. It needs to span 8 meters from the bottom of one side to the other. Does that help to clarify what this thing looks like? The 2 identical sides, okay, hopefully you know what that word means, makes an angle of 66 degrees at the top. You know what 66 kind of looks like in degrees? Well, it's bigger than 45 and it's less than 90. So that's the wordage. We need to make a picture. It's pretty tough to be doing this in your head without one. So the first question in today's assignment is going to look just like that. It's just got one more little thing added to it. So don't say, oh, it wasn't exactly the same, Mr. Watson. No, it's not, right? I'm going to make you think a little bit at least. So this is where I'm going to start. 66 degrees at the top. Okay? Roof. Does it look 66-ish? Okay. Okay, I'm not going to pull out my protractor and measure this thing, but okay, looks like more than 45, looks like less than 90. There's one number. I got another number in here. 8 meters. Where do you think that goes? From the bottom of one side, and that would be there, to the other, right? That's 8 meters. Any other numbers in this question? Nope. But I do know each side is identical. So what kind of a triangle is that? Isosceles. All 3 sides are equal. But how do we know that couldn't possibly be an equilateral triangle? Because that's not 60. The only way I can have an equilateral, every side's the same, that means every angle's the same. That's equilateral. I just told you, when 2 sides are the same. Okay? You sure? For a few minutes? All right. So, what am I trying to find here? What's the length of each side of the roof? Let it be x. But if you understand this is an isosceles triangle, isn't that also x? They're the same length. I just said that, right? So it's kind of like a tricky question in that sense. All right. What's the name of this chapter? Oh, look, sine law. See, it's easy today, but on the test, you're just going to get a triangle, and then you got to determine, do I use sine law or what we haven't done yet, cosine law? So sine law says A over sine A is B over sine B. Again, I need to know 3 pieces of information here to figure out anything. Either both sides in one angle or both angles in one side. I have to have 3 pieces of information. Do I have 3 pieces of information here? No, I don't. But how can I find this angle down here? If it's an isosceles triangle, what do I know? That's the same angle. So these angles are the same, and they have to... What's 180 minus 66? Yes, but let's check. 114. Whoop. Those two angles have to add to 114, but they have to be the same, because that's an isosceles triangle, right? So I could call that, I don't know, Z, Z. I got two Zs, they're equal, they have to add to 114, or some of you just thought, well, why don't I just divide it by 2? That's what Michael said. Yeah, same thing. Make sense? So Z, how many times does 2 go into 114? How about 67 degrees? Nope, that's not right. How about 57? Okay? Does that kind of make sense? That's 57. That's 57. Let's double check. These have to be the same. It's an isosceles triangle. Are they the same? Yes, they are. And 57 times 2 plus 66. Any three angles in any triangle have to add to 180, do they? Yes, they do. So it's got to be right. Okay? Now I have three pieces of information. I can solve for x. So again, if it helps, you can do this opposite thing, right? I know this side. To get that side, I got to know the angle opposite it. And I also have these two pieces of information. So I can write this out and go x over sine 57 is equal to the side 8 over sine of 66. Okay, how do I get x by itself? It says x divided by sine 57, so if I times it, the opposite of divide, it's gone. Whatever I do to one side, do to the other side. And x is 8 times sine 57. Make sure you're in degrees, which I'm not. 8 sine 57 equals divided by sine 66, or if you're really clever, you can put all that in at once. 7.3. Read the question to the tenths. 7.3. Okay, and then nice and clearly so the teacher can find it. Okay, do I have units? Yes, I do. That's meters. Does it look reasonable? Sure. Okay. 7.3 meters. I got one more, and you're on your own. You guys know what a telephone pole is? Even though, yeah, most of your phones now are wireless, why do they still call them telephone poles, even though many of them may not have telephone wires on there at all in a few years? Habit.
I have a question. Are we going to need to know who they both have instead of like equilateral or...
Yes, you need to know equilateral, isosceles. You need to know what those are. Am I going to ask you to spell it? No.
No, but like, is there anything with that?
What? Okay, hang on. Okay, now we got some proper language here. Don't worry about it, Cassidy. You need to know basis, okay? You need to know what isosceles means, right? You don't need to know the term, but mathematically you need to know the two angles are the same, yes. Yeah, great. Okay, it's better. A telephone pole is supported by two. Don't ask me why they came up with this word. I guess the first guy to do this on a telephone pole was named Guy. I don't know. Okay, but did we see this terminology in Math 10? Yes, Mr. Watson, we sure did. Because it was in there. Yes, it was. at least one question. So, especially even new trees. When you plant a new tree, you notice they put in stakes and wires and cables to hold the things in the wind so it doesn't blow over until it grows strong enough roots. And then it still might, but at least that way it's got a fighting chance. Okay? Does that one have any? No. But lots of times telephone poles will have some supporting wires in the ground. Okay? 2 guy wires. Anyway, the wires are 50 degrees apart at the top, just like our last question. This one will be a bit different though. And one wire is 60 degrees to the horizontal at the ground. I could have used some other terminology here, like angle of elevation, right? Does that say the same thing? Yeah, to the horizontal, to the ground, angle of elevation. But I didn't. The wires are 12 meters apart. Simple question. How high is the pole? That holds all our electrical lines. Sometimes we bury them in the ground. Makes it look a little nicer, but then if you're the guy that has to fix it and find the wires, it makes it quite a bit harder, doesn't it? Okay? So, telephone pole. What does that look like? Looks like a telephone pole. 2 wires. They're 50 degrees apart at the top. Okay, so that's 50 degrees. One wire, 60 degrees to the horizontal. So here's the ground. Does this look a little like the last question? Well, it's not. And what else do I know? It's on. No, that's grass. Just the cow hasn't grazed on it yet, so it's a little bit fluffy. Yeah, you're right. It does kind of look like water. Okay. Is that better? Okay. There's my grass. They're 12 meters apart at the bottom. Do we assume the other angle is 60 degrees? No. Do not. It's not told that in the question. You don't assume anything. Because did somebody wonder why I didn't just on the last question say, isn't that symmetrical? Couldn't you just take half that distance and go, that's 4? And then maybe just use SOHCAHTOA? Or do we not remember this right angle stuff? I could have. This question I cannot, because this isn't symmetrical. So what I first want to point out is, because I guarantee you, several of you on the test will try to do this, you will divide this 12 in half and go, hey, that's 6 meters. It's not. Even if my picture looks like it. I can't, what if one wire is like that? Do you think now that looks like 6 meters? Absolutely not. Okay, so just because you might draw it symmetrically, that doesn't mean these angles are the same. And if this is not an isosceles triangle, then this distance here is definitely different than this distance here. Okay, so that is not 6 meters. Now, I want to know how high the pole is here. I want to know x. Now, this is a right angle right here. Usually our poles we put in perpendicular to the ground, right? So they go as high as possible. And then they're least likely to fall over. Does that make sense? Kind of like walls on your house. You don't build them like that, right? So that's perpendicular. That's a right angle. So you might look in this and go, hey, my grade 10 stuff says sine of 60 degrees is opposite over hypotenuse. Let's call that y. And you would be correct. Only I can't solve this, right? I got two unknowns. I can only have one unknown, x. So I first need to get y. Okay, once I have y, then I just put it in there and solve for that. So how do I find y? Well, to get y, I need some sine law stuff. I need the angle opposite y, okay? Because I have these two pieces of information, I know the side opposite 50. So sine law says y over sine of, I'll call that big Y, is 12 over sine 50. But again, I have two unknowns there. But how do I find out angle big Y? It's 180 degrees in a triangle. Yes, this is exactly what you did on the worksheet last day. Okay? So y is 180 minus 110. Do I need to do that in a calculator? That's 70 degrees. Okay, double check it. 130 and 50. Yep, that's 180. So I'm going to put that right in there and go y, I'll write it out again, over sine 70 is 12 over sine 50. How do I solve this thing for y? Times both sides by sine 70. Okay, that's gone. And y is 12 times sine 70. Close the bracket, then you can divide 14.7. Look reasonable? Sure, that's 12. This is a hypotenuse. It's got to be long. Sorry, that's 12. That's not a hypotenuse. Yeah, it looks reasonable. 14.7. Now that's not a final answer, so I shouldn't be rounding this yet. Okay, let's put in a 2 there too. Because remember, this is what I want to put in there so I can get x. I want to know the height. Okay, now I got a right angle triangle. Now I'm back to grade 10 here. I know the hypotenuse. I know an angle. Okay, so put it back in here. Sine of 60 is, that's what I'm trying to find, the height over 14.72. How do I solve that thing for x? Yeah, times both sides by 14.72, or you can think, just cross multiply half of it. Same thing. 14.72 times sine 60 is x, and that is, I still got the number in my calculator, so don't clear it. It's already there, and this is more accurate than that. 12.75. It doesn't say, so let's just go tenths. 12.7. Is there units? Yep, it's in meters. That's the height of me pole. Okay? So, sine law, I actually did it twice. You can call that sine law if you want, but if it's 90 degrees, okay, the sine of 90 is just 1, cancels out. SOHCAHTOA stuff works. Okay, page 125. You already did 1 to 4. I'm adding some more. 5 to 8, 10, 13, and a quiz tomorrow. And then we're moving into cosine law, which is going to be a little trickier. So make sure you get this stuff down good. Coming?